Hello, this is RJ Garcia teaching you how to do the extreme value theorem problems. The first one, we're going to start off with an easy problem. Find the minimum and maximum values of fx equals x to the fourth minus 3x to the third minus 1 on closed intervals of negative 2 and 2, where the function is continuous from those intervals. As always in extreme value theorem problems, our first goal is to find the derivative, then find the critical points, and then lastly evaluate the points of the fx compared to the critical points, and find the max and min of the interval. See here, then we have the derivative right here as the next part. The derivative of this equation is 4x to the third minus 9x squared. That's because once you take down the 4 to the x, and then you get 4x to the third, then you take down 3 times 3 equals 9x squared. And then the negative 1 disappears. Next thing we have to do is solve for the rest of the critical point. So now we have to do the critical point, which was x squared. I mean, once you factor out the 4x squared minus 9x squared, you get 4x minus 9, or 4x cubed. That's written wrong. Equals 0. Then you have x equals 0, and then x equals 9 fourths. However, 9 fourths is not on the intervals of negative 2 and 2, so 9 fourths has to be crossed out. So what you are left with your one critical value of 0. Next step is to evaluate the value between the values of 0, negative 2, and 2. And when you find that, you see that the other critical value is 0 and negative 1. And what you find is that when you plug in f of x to negative 2 and 2, you get 39 and negative 9, which is proven to be that the max of the value is negative 2 equals 39, and the minimum value is f of 2 equals negative 9. Alright, so now we're going to move on to the hard question, which is slightly more difficult. The hard question is f of x equals 1 over 1 plus sine x on 0 to pi with closed intervals. The function is continuous from 0 to pi. In this sense, you have to use a special rule to factor out the derivative, and which turns out to be negative cos x over 1 plus sine x to the squared equals 0. So once you factor that out and you set it to 0, you realize that since it's in the negative, the 1 plus sine x squared means nothing for you for your to solve for. Then you solve for x, you set cosine of x equals 0. Then you find that cos x equals 0, cos x equals 0 equals x to the 1 to the pi to the 1/2. And then you build a nice little t-chart like this to figure out to evaluate your values. So you have 0 and pi, which are both equal to 1, and then you have 1/2, and then you have pi to the 1/2 over pi. You have pi divided by 2 and 1 divided by 2. So what you find from there is that your two maximum values are 0 and pi, and your minimum value is pi divided by 2, which equals 1/2, and 0 and pi both equal 1. Now we have the challenging one, or the extension problem, or whatever you like to call it. Now, extension problem is how can you solve and how can you prove the extreme value theorem by only using rules in calculus AB. Ponder that one after this, and that will be your extension problem. Thank you so much, and have a phenomenal day.